for the introduction, power generating systems are generally treated as heat engines to convert heat input into work, hence to produce electricity at a sustained rate. Heat input is supplied by burning fossil fuels such as coal, oil and natural, and biomass, or processing nuclear fuel or harvesting thermal energy from renewable energy sources. For example, in a conventional coal-fired power plant, the energy of coal is eventually converted into power. In general, conventional power stations comprise multiple generating units which are designed to operate at their nominal load when they function optimally. Conventional power generation systems produce electricity at a frequency that is a multiple of the rotation speed of the machine. Voltage is usually not more than 6 to 40 kV. The power output is determined by the amount of steam driving the turbine, which depends mainly on the boiler. The voltage of that power is determined by the current in the rotating winding of the synchronous generator.
Bismillahirrahmanirrahim. So let's move on to the structure of the system. There are three main types of generating stations, which are thermal power plant, hydropower plant, and nuclear power plant. And for thermal power plant, it consists of boiler, drum, burner, forced draft fan, induced draft fan, turbine, generator, condenser, and as well as reheater. And for hydropower station, it consists of dam, generator, transformer and power lines, and as well as turbine. And for the last one, nuclear power plant, it consists of reactor, steam generator, turbine, generator, and condenser cooling water. So how actually those three types power plant works? Well, first, the thermal power plant. The heat energy obtained from the combustion of solid fuel is used to convert water into steam. The steam then produced will be at high pressure and temperature. The steam moves over the blades and it causes the shaft to spin. And this spinning shaft is connected to a rotor of a generator. And the generator then converts the kinetic energy of turbine impeller into electric energy. And for hydropower stations, the conventional one must at least have four main components, like I said before, which are dam, turbine, generator, and transmission lines. The dam controls and raises the water level of the river to create a falling water. The force of falling water then push against the turbines causes the turbine to spin, and the turbine then converts the kinetic energy to electrical energy by the presence of generator. Lastly, the transmission lines conduct electricity from the hydropower plants to homes and business. And the last one is nuclear power plant. For nuclear reaction, nuclear reaction uses fuel made from mined uranium to make steam and generate electricity. Nuclear station therefore contains a synchronous generator, steam turbine, condenser, and cooling system. And the working principle is based on fission and fusion. Fission is when a nucleus of an atom split into smaller components, releasing energy to steam the water. And fusion is when a smaller atom encouraged to fuse at an extraordinarily high temperature to form a larger atom. I think that's all for structure of the system. Thank you.
Okay, right now I will be explaining about everything, some of the problems that the generator will face while they are outputting any power. So the first one will be the neglected or poor maintenance. So we know that the generator are very important in continuous power generation. So once as to say that the continuous generation, especially in thermal or the hydropower plant that requires all year long working conditions, the material will be straining, and then it will be destroyed as well. So the second one is a poor and inexperienced team. So as a generator design is last for years, many personnel do not have the hands-on experience or proper identifying for repairing for the generator. Identify issue pose the highest risk, as the problem will pose crucial failure to a generator, or it will be a sign for future damage. So that will cause a catastrophic failure in the times ahead. The power generation are still reliant on only a single source of energy. Okay, we can say that such as coal, natural gas, or even water or nuclear generator cannot use any other energy as a source to generate electricity itself. That's why occasionally when the flood hits the power plant itself, the generator will render it inoperable at all, because the generator was extremely big and bulky for it to deconstruct and then assemble in another places.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adad Iskandar Azman dan saya akan meneruskan untuk problem phase. Next, underground cable. A major reliability concern pertaining to underground cable is electrochemical threading. Threading occurs when moisture penetration in the presence of an electric field reduces the dielectric strength of cable insulation. The dielectric strength is degraded sufficiently transit caused by lightning or switching can result in dielectric breakdown. Next, transformer failure. Transformers are critical link in power system. Take a long time to replace it, they fail. True fault cause extreme physical stress on transformer windings and the major cause of transformer failures. When a transformer become hot, the insulation on the windings slowly break down and becomes brittle over time. The rate of thermal breakdown approximately double for every 10 degrees Celsius. Next, gas turbines. Gas turbines have a large property damage loss potential due to expensive replacement part and high loss frequency. Not prone to losses and can normally be repaired within a reasonable period of time. Failure of gas turbine blades can be due to creep damage, high temperature corrosion, high temperature oxidation, fatigue erosion, and foraging object damage. Most failure is due to the interaction of more than one failure mechanism.
Okay, right now I'll be explaining what are the solution for when facing the generation issue itself. First, I will say that we can design a detachable generator, or simply put the generator that was the simple concept as simple as the Lego itself, which means that the generator will be able to deconstruct or refit into using another energy source. So the second will be reviewing the training program itself. So by introducing the reference material such as pictures of the damage inside the structure, and lead by an experienced engineer which handled the repairing before, we will have the experienced worker will able to get insights from the previous veteran engineer itself. So and the engineer itself will be able to identify any minor symptoms that was the hint from any damage, which will be usually be ignored by any newcomers. That will give us a swift and short response time to avoid damage inside the internal generator, and saves repair costs. Okay, so the third one will be introducing additional detection hardware as a safety measure. So it's pretty simple, such as device that was internal device that can measure the PSI, the pressure itself, or the any thermostat for checking temperature. So by taking, because this detection hardware is by taking the maintenance into consideration, so the hardware which are easily accessible for the workers itself will allow teams to predetermine and pinpoint the potential fault inside the structure.
For solution of failure related to electrochemical treating is the method for cable testing is to inject a small signal into one and check for reflection that will occur at partial discharge point. Other methods are measuring the power factor over the range of frequency, the electric spectroscopy, analyzing physical insulation sample in a lab for polaritic breakdown, degree of polymerization, and using cable indicator to test the hardness of insulation.
Hello, today I will explain about the conclusion of our assignment. In conclusion, the finding shows that indeed the generator will face many issues during its service lifespan, external or internal. Proves that preventative measures is invaluable for maintaining a constant supply of power, as power is crucial to daily activities. By identifying the issues, we are able to devise a countermeasure for different scenarios. Whatever its natural occurrences or human error, we can prevent or minimize the damage taken so that constant power is supplied. With the current countermeasure, although it's the latest, we can agree that it's not perfect. This project provide us insight into the work field and better prepare us for the future to come, as well as encouraging new ideas and innovation. As we become the main contributor to the nation in the future, acquiring all types of knowledge and researching will act as an important part towards building a prosperous and modern country. That's all from us. Thank you.